Good morning, good afternoon, and good evening, everyone. I'm Prerna Pradhan, and I will be your host for today's webinar. Thank you all for joining us from different parts of the world. Welcome to AlCircle's webinar on autonomous furnace tending in aluminium cast houses, improving safety, productivity, and yield. Before we begin, let me briefly introduce about AlCircle. I'm sharing my screen. AlCircle is a global virtual aluminium ecosystem that connects the entire aluminium value chain from bauxite and alumina to primary metal, downstream products, and recycling. Under this ecosystem, we have three key platforms, which is AlNews, AlBiz, and AlLearn, each designed to support the aluminium industry through news, business connections, and knowledge-led insights. AlNews is the heart of our information-related products. It includes latest industry news, custom reports and market intelligence, exclusive interviews and e-magazines, latest price and industry events, expert blogs, and opinion pieces. AlBiz is the one-stop online B2B marketplace connecting aluminium equipment, consumables, buyers, and sellers. It is the buyer-seller matchmaking, the surplus marketplace, your assisted trading support, and the 360-degree marketing solution. AlLearn is our newest initiative to create the world's largest online repository for aluminium. It aims to inspire and empower the next generation of industry leaders while also serving as a critical tool for those already shaping the future of aluminium. Today's webinar aims to help cast house professionals understand how autonomous furnace tending equipment can improve safety, productivity, efficiency, and yield in aluminium cast house operations. Let me introduce today's speaker, Mr. Mark Bumford, the Sales Director of RiA Cast House Engineering. Before I hand over the session to Mark, please take a note on the webinar ground rules shown on the slide. So we will take questions at the end. All attendees are to mute their systems during the presentation. If someone wants to talk, they need to raise their hand, unmute, and then speak. If attendees have any question during the presentation, they can share them on the chat and we will address them during the Q&A session. It will be great if the attendees switch on their videos during presentation and while interacting with the speaker during the Q&A session, and promotional activities will not be entertained. So hereby I end my intro, handing over to you, Mark. Also, before we start, let me just put on one more thing. The deck, the recording of the session will be shared to all the participants post-webinar or within this week. Thank you.
Okay, thank you very much. I'm just sharing my screen now. And with that click, the slides should be visible to everyone.
Yeah.
Okay, I'll jump right in then. I would like to also extend my appreciation to AlCircle for organizing today's webinar to give us the chance to interact. And of course, I'd like to thank everyone who's taken time out of their day to join today's proceedings. And also a warm welcome, good morning, good day or good afternoon, depending on where in the world you are participating from. I'm actually sitting in the United Kingdom right now. My name, again, Mark Bumford. I am Sales Director of RiA Cast House Engineering, but I'm also Sales Director of an associate company called Fiascope GmbH. And I'll talk about the products of both of those companies and how they're tied together and how we come to have the cooperation and work together. So, first slide I'd like to show you is to give you a little bit of background on our experience and how far we extend back in the industry. We actually started business under the brand name Rackfits Industrianlagen, GmbH, in the late 1990s. So not long after the reunification of Germany, when East and West rejoined to become Germany. Prior to that, there was an aluminium company in the town of Rackwitz, just outside of Leipzig, and our founder was technical director of that company. He set up Rackwitz Industrieanlagen, the building where we have our workshop today, was the maintenance workshop for that large aluminium company. The aluminium company still exists, so our next door neighbor is today part of the Hydro group. There's a RiA Cast House and downstream extrusion. So as you can imagine, our experience came from both those areas, cast house and downstream extrusions, and we offered products to both of those areas in our early days. In 2018, our founder retired and his son took over the business, and he chose to rebrand the business as RiA, R-I-A, taking those letters from Rackwitz Industrieanlagen. And we refocused the business specifically on two core products that we'd had a lot of success with. And that was furnace charging machines and furnace skimming machines, rail mounted. I'll talk about those in detail in the coming slides. In 2019, we established a business in the United States to support a growing installation base there. Trump's first term, a lot of cast houses were built or invested money. We saw a lot of that business, and we now have an entity in the United States to take care of spares and service and support in the United States, as well as sales activities covering the entire Americas. I mentioned that there's a second company involved, that's Fiascope GmbH. We are separate legal entities, but we work very closely together. Our association goes back to 2014, when RiA purchased the first cameras from the business that is today Fiascope, and we integrated those cameras and put them into an aluminium furnace. The very first time we did that, 2014. I'm pleased to say that those cameras are still in operation today. One is original, one was damaged during a reline and was replaced, but otherwise would still be working today if it wasn't for the reline. That took place in 2022. So the first camera still operated for 8 years in that application, and the second camera is original. It's been operating for 12 years. We signed an exclusive agreement, we RiA, with Fiascope in 2021 that we would not buy anyone else's cameras. They wouldn't sell their cameras into aluminium industry through anyone other than RiA. And we went one step further in 2022, where our managing director became joint managing director of Fiascope. I became sales director of Fiascope, as well as sales director of RiA. We relocated the business to share our offices in Leipzig. And as well as sharing offices, obviously we share resources. So my sales team took over the sales for Fiascope worldwide in 2022. Whilst still trying to establish experience and credibility here, we have approximately 101 rail-mounted machines worldwide. And that's split approximately 2/3 charging machines, 1/3 skimming machines. At the moment, this year, we're seeing a lot of demand in skimming machines, more so than usual years, and the numbers are ramping up there. So, for example, commitments this year for skimming machines outnumbering those on charging machines. Our market is approximately split equally between Europe and the Americas, although you see on the figures here, we have slightly more installation references in Europe, which makes sense. It's our home territory, it's geographically closer. The Americas coming a close second, and Asia being a relatively newer market area for us, just a handful of references there so far. We expect also to be active in the Middle East before the end of this year. The logos here represent our key customers. What the story doesn't tell is how many references each of these individual customers have. Our largest customer, for example, is Hydro Aluminium. We were selling to Hydro before they merged with Sapa, so Sapa was also a large customer and user of our equipment, and when they merged, they became our single largest customer. Other major names in the industry that are recognizable, well-known, Hindalco in India and their downstream rolling arm and recycling part of the group, which is Novelis, Kaiser, Logan Aluminium, Texarkana, etc. And you see along the top some of the furnace builders, GNA out of Canada, Jasper from Germany, and Incitec from Spain. These are also customers of RiA, having purchased our charging and skimming machines and incorporated those into a package that they've offered for perhaps a greenfield site or a brownfield site with a new cast house expansion, but typically in conjunction with new furnaces. So what is it specifically that we do? We offer charging machines which are multi-directional. By that, what I mean is our machines will often move left and right in front of the furnace, particularly if you have a row of furnaces that are in line, then the machine will move left and right and stop in front of the appropriate furnace and charge it. When we're working with single furnace applications, it may be that we move forwards and backwards to the furnace. And those decisions will be taken really by available space if it's an existing cast house. Or space that's available for the deemed footprint of a new cast house in greenfield situations. We can also have what we call an angled movement, where the rails are installed at an inclined angle to the furnace and not parallel to the furnace door. So as we move to one side, we move further away. Reason for that is to give more space to actually load the machine. And again, these decisions about directions of movements are often governed by where the scrap comes from. Where are you going to bring the scrap from to put into the charge container? And we can offer bi-directional movement. That's often where rails are installed into the floor in perpendicular arrangement, so that we can move on one set of rails, bring down a second set of wheels, and transfer onto a second set of rails. And that allows us to move backwards away from furnaces and past perhaps building columns that might be in the way in existing cast house situations. So all of those options are available, as well as having a machine that completely swivels, again, with rails that may be in the floor that are installed in a circular direction, or having a container that swivels on a fixed base. So the machine will move and the container can rotate 90 degrees, 180, 270 degrees, again, depending on where the scrap comes from. Now, our machines have been fully automatic since the year 2014. We stopped supplying machines at that time with an operator cabin on the machine from a safety point of view, which meant the machines needed to be automatic. We introduced autonomous a couple of years ago, and in the slides to come, I'll explain the difference between the two. What is an automatic machine? What is a truly autonomous machine? And how you can upgrade from one to the other. We've also supplied charging machines for tilt rotary furnaces. In that case, we supply pusher type charge machines. Traditional technology for rotary furnaces is vibratory feeder. They tend to make a lot of noise and generate a lot of dust. We have pusher type, same concept as we use for our reverb furnace charging or multi-chamber furnace charging machines. We also have transfer cars for heat treatment applications. A lot of our customers are billet producers, so transferring billets into batch homogenizers. But not just billets, we can do that for coils as well, coil transfer cars. When it comes to skimming machines, we offer telescopic type skimming machines. That's quite common and doesn't necessarily need an explanation. Most people have seen a telescopic type skimming operation. But we also offer carriage type skim cars, and that's where we have a fixed length boom that moves up and down on the carriage, and the carriage moves left and right. Not telescopic, and there's advantages why that might be the case. We can talk about that in slides to come and questions later. Our skim cars can also be bidirectional like the charge cars. Now that might be important in a cast house with multiple furnaces, where you might want to swap the position of a charge car and a skim car. You can move a skim car backwards and out of the way, allow a charge car to move in front of it, bring the skim car back, and you've swapped positions. That means you can go skim furnaces down on the other side of the cast house without being in the way of the charge machine, and allowing the charge machine perhaps to go to a loading position to be loaded ready for the next charge. Now, our skimming operations are also starting at manual, but more often these days automatic and autonomous. And again, I'll explain the difference between automatic and autonomous. When we offer stirring and mixing, which is part of the function of the skimming machine, although it's called skimming, it's also used for stirring and mixing of the bath. That can be done in an automatic mode. We can do the hot cleaning of the walls and the floor between alloy change, and that can be also an automatic process. Whilst the machine is not designed for load spreading, it gets used for load spreading. We're aware of that. The machine has the forces capable to push heavy loads inside the furnace towards the back of the furnace, or drag them forwards towards the front of the furnace. And I have a video, and I'll show that in operation and explain why that might be useful to you in practice. And then finally, we offer a patented technology which is unique to RiA. It's called in-furnace dross pressing, and I will show a video with that in operation shortly. Why have we been successful with charging machines? So let's focus on those points that we said that we would cover in the presentation, safety being the first of them. Looking at the image you have of this charging machine, there's not an operator cabin visible. There is no operator cabin on the machine. I mentioned that in an earlier slide, that since 2014, we've not supplied one machine for charging with an operator cabin. If there's no operator cabin, it needs to be activated remotely. We supply a remote desk for that. There'll be a single push button on that remote desk, and the operator just simply selects which furnace he wants to charge, presses the button, the machine takes care of the rest. I will show videos and graphics to show what I mean by takes care of the rest. If the operator's not on board the machine or can't be on board the machine, he's away from the risk of splash, the exposure to heat, or worse still, the risk of an explosion. All of our machines incorporate safety laser scanners, so that means, and that's visible in this graphic at the front here in the middle of the machine, we scan across the full length of the machine, and as the machine moves along the cast house floor, if there is an object in the way, be it another vehicle, a person, or a piece of scrap that's on the floor, the machine will slow down as it approaches the object. It will stop if the object doesn't move, and it'll continue when the object's out of the way. Our machine knows exactly where it is through the use of lasers, measuring against a fixed point inside the cast house. So when we go into automatic mode and you select the furnace, the machine will move to the furnace knowing exactly where it is. The center line of the machine will match with the center line of the furnace. It will send a signal to the furnace controller to open the door. It'll extend into the furnace, deliver the load, retract, send the signal to close the door, and move back to the loading position. That is what we call fully automatic. If it's a rotating machine, when it's in the loading position, it'll rotate into the appropriate orientation. When the operator is ready to charge again, he pushes the button again, and if it's rotating, it will swivel and then move to the appropriate furnace and repeat the cycle, come back to the loading position. That's automatic. It's triggered by a human being pressing a button on the remote operator desk. What do our machines offer in terms of productivity benefits and efficiency? Higher melt rates. We look to deliver the maximum load possible, so we fill the width of the furnace and the height of the furnace door, coming just a few millimeters below the lintel and above the actual sill itself. That way we get the biggest cross-sectional area that we can. We tend to extend deeper into the furnace than other people's technology, and then deliver the load to the back of the furnace and evenly across the floor. That gives a shallow scrap pile with a bigger surface area and leads to higher melt rates. We do that always less than 90 seconds. The biggest machine we supplied so far to date has a 64 cubic meter capacity container. It's rated to 30 metric tons. It extends out 6 meters from the front of the machine and can push 30 metric tons into that furnace in less than 90 seconds. The fastest machine that we've supplied is just 35 seconds. And that machine delivers a 15-ton load in 35 seconds into the furnace. So if we can get more material into the furnace, we may reduce the number of door openings. And if we can do that as quickly as possible, we'll reduce the amount of time that the door is open. So we'll reduce heat loss from the furnace, we'll reduce oxygen generation going into the furnace, which will lead to more oxidation of aluminium and dross. So we minimize those things, we improve your efficiency, and we improve your productivity. Additionally, putting that much material into the furnace in one push from our machine reduces the amount of other vehicle movements in the cast house, safety again, but also will ultimately lead to less maintenance in the cast house. All of our charging machines have load cells, which are installed above every wheel that the machine has. So if the machine has 4 wheels, 4 load cells, 8 wheels, 8 load cells, they tell us how many kilograms are in that container. So we can record each push, how many kilograms we put into the furnace, and per cycle, how many kilograms in total we've loaded into the furnace from the charge machine. That'll help you with tracking what your recovery rates are. Why no operator? And I apologize for the shocking slides. I found them on the internet. I can't even tell you where these accidents occurred. That's not as important. The important thing here is that if an operator is driving a mobile vehicle, it doesn't matter if you have a cab that you think protects him, it doesn't protect him from a potential explosion. You look on the left one, you can see a lot of dust there. You can see sheeting which appears to have come from the roof. The one on the right, aluminium has splashed back past the forklift truck, and the forklift truck has caught fire. In both cases, I hope that the operator, the driver of these vehicles, was safe and went home uninjured, and actually went home to his family. But the fact that the driver was there, he was at risk. In the case of our machines, there will not be a driver on the machine. And if an unfortunate accident like this occurs, then there will not be injury to the operator of the machine. So the graphic that's playing now shows you typically how one of our machines functions. It's moved to the furnace, sent the signal to open the door. As soon as it knows the door is open, it extends into the furnace. The video in the top right is synchronized to the graphic that we're seeing here. So we extend 2/3 into the furnace, bring the pusher plate to a predetermined point inside the furnace. Some of the scrap is falling off the container at this point to the back of the furnace. And then we retract the container against the fixed pusher plate. Now we're distributing the load evenly all the way across the floor of that furnace. And when the front of the container comes back to the same point that the pusher plate is, the container is empty. So at that point, it can retract out of the furnace. And we know when we clear the door, we can send the signal to the furnace controller, close the door, and we start to move away from the furnace back to the loading position. The time taken, and if you had timed that little graphic, that was 90 seconds. And that's the longest we'll ever take. We've never produced a machine that took longer than 90 seconds. Here it is in reality. Now, the video that you're watching here was not actually created by RiA, but it is a RiA machine. It was created by Hydro, one of our installations. The important thing here is the words that you see about circular economy and everything else that come from Hydro, not from us. So here, safer, more sustainable, cost-effective. Hydro's interpretation of having implemented this charging machine and many other charging machines in their other cast houses across 10 countries. A new automatic foundry loader, as they refer to it, making scrap loading easier and safer. The machine is complete here. Again, that was fast forward in that video. The machine isn't in reality that fast. We tend to show the videos in real time. And it's moving away from the furnace and the door is closing. No operator cabin on the furnace. The operator to the right of where the video is taken, the operator has a remote operator desk and a single push button. After he presses charge, he doesn't even stand and watch the machine because it does the same thing every time. He's now free to go do something else. Here we can see one of our remote operator desks in a pulpit, environmentally conditioned location for the operator. Looking through the window, you have line of sight of one of two furnaces. We have an onboard camera on the charging machine so the operator can see what's in the container and how the container is interacting with the furnace from an elevated position. And over on the right-hand part of the desk, you can see another monitor there, and that's actually showing a video from our skimming machine, which you can just about see in the background when you look through the window on the pulpit there. So that's a typical remote operator's desk. There's a push button to charge, and there are two melter holder furnaces in this particular cast house. So there's two buttons for the operator to choose. There are joysticks if you want to manually move the machine out of the way or carry out any functions manually, but typically it's just simply push the push buttons. I'm going to talk now about cameras and how those get tied into what we RiA offer and how cameras can be offered as a standalone product by Fearscope. Again, users of the cameras, you see a lot of common logos. A lot of those customers bought cameras through RiA as part of their package. For example, if they purchased autonomous furnace charging, they would have bought a package which included the Fearscope's cameras, in-furnace cameras that we supplied. Some of these customers are users of cameras, but not users of our machines yet or today. That's something that we would like to change for the future. So a lot of similar customers that I'm sure around the world you'd recognize, a number of these major names. Our biggest single customer for the camera technology is Novelis. But their upstream facilities in Hindalco are also using the camera. You'll see some furnace builders as well, again, along the top line, Jasper out of Germany, GHI out of Spain, Mecatherm from the UK, GNA again out of Canada, Incitec from Spain. All of these have bought multiple cameras from RiA for multiple applications, multiple locations. What I want to show you now is footage that was captured from our very first cameras. Remember, these were installed in the year 2014. This footage comes from the year 2015. It's an explosion. I'll start the video playing. It's possibly the only in-furnace footage of an explosion captured. We've all seen explosions from outside of furnaces, but what happens inside the furnace? Now, this sow in the middle had just been charged, doors closed, burners turned on, and the bubbling starts here. So you've got one sow in the middle and you've got another sow next to it. This video is clipped and fast forward so we don't have to sit through 10 minutes, but 10 minutes of bubbling was visible in that raw footage. After 10 minutes, everything went calm and smooth for literally a second, and then the explosion. And you see the sow was flipped to the back of the furnace, and I will take this back and stop just after the explosion. You can see the sow that was in the center here was flipped to the back of the furnace. The sow that was to its right flipped against that back wall. You can see a dark area in the sow here, and many experts have analyzed this footage. We don't talk about where it was. That's not important. The idea is to educate the industry here. And the opinion from the experts is that the contraction contained moisture. The moisture initially evaporated, vaporized, escaped as bubbles, and at a certain point the sow started to soften and contract upon itself, trapping any moisture, which rapidly expanded and led to the explosion. In reality, it was a very loud bang, but the furnace wasn't damaged. Our cameras continued to operate, and afterwards the operators closed the door, carried on with the cycle. It got us thinking. That was 2015. What else could we do with those cameras? And that's why we started to take that technology and integrate it with our machines. And that's what I'm coming to shortly. So with a Fioscope camera, what do we supply? We have a camera, we have a pneumatic retraction. We have an air blower, which provides the majority of the cooling for that camera. There's no water cooling, it's all air cooling. We supply an electrical control box and a pneumatic control box. We ask the client to bring us power and to bring us compressed air. The compressed air feed we also take to the camera, and we use the compressed air for rinsing purposes in the very center of the camera to keep the optics clean and to prevent ingress of dirt. The cooling, as I said, comes mainly from the blower. We have a backup secondary cooling in case of failure of the blower. And we have safety inbuilt with the retraction mechanism that if the camera gets too hot, if the power fails, the camera can automatically retract. At any time, the operator can choose to retract the camera. So the camera is normally permanently in the furnace unless the operator chooses to remove it. We have numerous applications that link the camera retraction to the door opening, because when the door opens, typically something's coming into the furnace, you're charging or you're skimming, and these are places or occasions where there could be splash. So if the camera's retracted, the camera's not going to suffer that splash. On the outside of the furnace, this is what it looks like. So we have the pneumatic retraction and the camera probe. Here it's retracted. We have the cooling fan and the hose that feeds that air. And then we have various pneumatic connections to the bracketry here that cool what we call a cyclimal tube, which is internal inside the refractory itself, and some cooling here to the camera. Coming out the back of the camera, we have temperature thermocouple measurement, and we have the data signal for actually display on monitors. Here, bottom left, we see the electrical control box and the pneumatic control box. And out on the furnace, apologize for the lighting, cast houses are not the best places to be taking videos. You see when the camera retracts, and I'll play the video again, there's enough space at the front to actually get a hand in with a cloth and actually clean the very front part of that camera probe. And we call the front part sacrificial glass. And by the very nature of the name, that glass is sacrificial. It's there to take dirt, it's there to take splash, and can ultimately be replaced simply, and it's more cost effective than replacing the actual optic or the lens itself. And if I play the video one more time, the observant of you may notice a counterweight over on the left here, and that just closes a flap. So when the camera comes out, the flap comes and seals that box and seals the furnace back off. Okay, what are we using the cameras for, and how does that relate to charging machines? This video I'm going to show you now, you see a scrap pile and you see an overlay on that scrap pile, a polygon, which is green in color. We have a traffic light system. Green means go, same like the traffic lights. What we're going to see, now that furnace is ready for charging, the door is going to open. So the burners will stop. Everything will slow down here to real time. We'll bring the charging machine in, and we'll put another load on top of the semi-solid, mushy contents of that furnace. And we know that bringing the charge machine in at this time, because we've identified the topography of the scrap pile, we know that the scrap pile is not going to interfere with the container, that we don't hit something solid and have to back out of the furnace. We now see a red polygon because the AI system is identifying that the scrap that's in the container would be too high to make another charge. So the polygon is red for the time being. The charging process finishes. We'll go back to fast forward now. So door closed, burners back on, scrap starts to melt down. The red polygon, like the red traffic light, means stop, don't go. We're tracking the scrap as it melts down, and we're looking for the point where it's lowest we can charge. We get orange or yellow, depending on where in the world that you describe that middle light on the traffic light, which says we're nearly ready. That's an indication to the operators, be ready with the charging machine. What we're actually waiting for is that billet to just drop down, that end of the billet. When he drops down, it's low enough now that the charging machine can come in and we can repeat the whole process. So in autonomous operation, we put the smart camera inside the furnace, and the smart camera tells the charging machine when the furnace is ready. You can have one step in between if you wish, where you can have the camera and the operator can make the decision based on the image on the camera, or the operator can allow the camera to tell him now is the time to charge, and he can push the button on the remote operator desk. These cameras just simply or can simply replace the need for the operator to press the button to charge the furnace. Skimming. Why have we been successful with skimming machines? Skimmers are, as I mentioned earlier, designed for not just skimming, but stirring and cleaning the furnace. Load spreading, that's not what they were designed for, but we know they get used for that. Not just melting furnaces, but holding furnaces. The prerequisite here is that the furnaces are in line, the doors are in line. They don't have to be perfectly in line because we can work with a bidirectional machine or work with the actual stroke and length of the machine to make sure we can reach all parts of the different furnaces. But the point is they can't be one behind the other or with doors that are perpendicular. Again, increased safety. Typical ways of skimming furnaces is a forklift truck or a mobile vehicle driven by an operator. We can eliminate the need for an operator to be on the skimming machine by making the machine fully automated or fully autonomous. And again, I'll explain the difference between those two. One of the additional benefits that a skimming machine provides is it's protecting your refractory and increasing potentially the refractory life that you would typically expect. Why? Because a forklift driver or a mobile vehicle driver has to judge the distance in the furnace. And if he's moving forwards and backwards and he gets the accelerator and the brake the wrong way, there's going to be contact with the refractory. And that's quite common. And over time, that will wear and damage the refractory. We'll program into our skimming machine, where is the back wall? Where are the side walls? Where is the floor? We can skim your furnace and guarantee not to touch your refractory. We can stir your furnace and guarantee not to touch the refractory. When we hot clean the furnace and clean the walls and the floor, of course, we have to touch the refractory, but we can control the speed with which we approach the refractory and the force with which we touch the refractory. As with charging, using a skimming machine to do this process, you're going to limit the number of vehicle movements inside the cast house and limit the ultimate maintenance that's required on those vehicles. The machine is largely electrically driven, whereas our charging machines are fully electrically driven. There is a small hydraulic power pack on this machine, which is just to control the angle of the boom. And in those cases, we put that hydraulic power pack at the back of the machine where it's furthest away from the heat, the exposure from the heat from the furnace. The boom is much more rigid than you would see on a tool being carried by a forklift truck. We don't suffer from the bowing. We don't suffer from the bouncing that you would see otherwise. The boom is not submerged into the liquid based on setting the pivot position in the right position for the furnace. We don't get submerged, therefore we don't see dissolution on the boom. We don't need to cut and weld and repair the boom like you do with other mobile tools. We air cool that boom to reduce the risk of the rapid heat rise when it's in the furnace, and then the heat drop and fall off when it comes out of the furnace to only rise again when it goes back into the furnace. So we put a blower at the back of the furnace, we blow air into the boom, which escapes out the back of the boom, so not into the furnace itself, and that keeps that boom at a more regulated temperature. Then quite simply on a skimming machine, we can add the modular addition of in-furnace dross pressing, which we'll cover shortly. Load spreading. So this is the moving of solids inside the furnace. And the video that I'm going to show here was captured by onboard cameras. They were on the skimming machine because they're ultimately used for autonomous control of the skimming machine. But what we can see is an uneven scrap pile inside the furnace. On the right-hand side, you can see liquid. There's no scrap. Potentially when the charge car put the load into the furnace, that side of the charge car contained smaller scraps which melted quicker. And the larger lumps were on the left-hand side of the container. They're taking longer to melt down. So if I play the video, you can see that we can push and we can pull, and in some cases, a couple of tons of material that we can move about. And we expose the inner part of the scrap pile, which was a long way away from the heat and being protected and insulated. We expose that then to the heat of the burners when the doors closed and the burners are turned back on. We also bring the scrap pile down to a lower level so that we can potentially bring the charge car in again and load sooner rather than having to wait for that side to melt. So that's load spreading. This video shows stirring, and we've come across many facilities that like to stir their furnaces in different ways, even with a circulation device on the furnace. The customers often like to do a final stir before they transfer the equipment, the liquid, to another furnace for holding purposes, or even stir in the holder prior to actually making a cast. And we can replicate any stirring pattern that you want or any duration that you want. If you want a quick stir that just takes a couple of minutes, we can do that. If you want a long stir because you've just put alloy into the furnace, we can do that. So you can just select which program you want. The machine will follow that desired path and duration that you ask for, and it will not touch the wall or the back wall or the floor or the ramp. It would just move backwards and forwards in that liquid and just mechanically stir prior to the end of the process. Then autonomous. So autonomous requires the addition of those in-furnace cameras, but we put them this time on the skimming machine itself. So the same technology coming from Fearscope with the same AI software capability. The operator selects the furnace that he wishes to skim. The machine moves into the center point in front of that furnace and the door opens. First thing the cameras do is identify the bath level. So you can actually skim a furnace automatically, and the machine will follow a robotic pattern lane by lane to remove the dross from the furnace. But without cameras on board the machine, smart cameras, the machine will get to the right-hand side of the furnace and say it's finished without knowing that dross may have moved from a dirty lane into a clean lane, and actually there's still a pool of dross floating around in that furnace. So in this case, the AI system will identify that dross and take the skimming machine back to remove that dross to make sure everything's removed from the furnace. And to show that again diagrammatically, if we put a grid across that bath surface and analyze each individual square and think about the cleanliness of that square or how much of that square is covered by dross, we can determine where do we need to put the dross, where do we need to put the skim blade to remove that dross. And here you can see diagrammatically, as we remove the dross, we're recalculating that cleanliness and telling constantly the skim machine where it needs to go to bring that dross out of the furnace. In reality, here's an example of a machine that's working. You can see there's a cabin on the machine. Door is open. Nobody is inside the cabin. So once the machine has been commissioned, the operator cabin has no value other than if someone wanted to climb on board and move the machine for maintenance purposes. Equally, that could be done from a remote location, and this cast house does have a remote desk behind the furnace. So from that remote location, the operator selects which of the furnaces they want to skim. There's a melter and there's a holder. This is the holder. The machine's moved into the center point. The door is opened, it's analysed the bath level, it's analysed where the dross is, and if I allowed the entire video to play, it's about 6 minutes. If I move my cursor to the right here, 6 minutes, 30 seconds. That is the entire skim process, start to finish on that furnace, including cleaning the bridge and cleaning the sill plate afterwards, which is all done through the use of the smart cameras, so that once the dross is brought up onto the sill, the smart cameras are identifying where it needs to go back to clean that sill. And if it's aluminium that's frozen on the sill plate, it'll also go and clean that off as well. Through the addition of a cold plate, and if I move my cursor and show you what I mean by the cold plate, which is at the front of the skim machine, and changing the skim blade from a flat rolled steel skim blade to a cast steel skim blade, which is profiled, and a matching but female version of that profile blade, we can bring the dross off the surface of the bath up onto the bridge and press the dross between the cold plate and the skim blade. And that is what we call in-furnace dross pressing, IFDP, and it's a patented process unique to RiA. We can add that to any of our skimming machines. Here it is in reality. So all of the operations and movements that you see are fully automated. So there's not someone driving this machine and using the joysticks. It's all been automated. So the cold plate comes up and sits on the ledge. The dross is brought back towards it, and the dross is pressed between the blade and the cold plate. Now, the cold plate acts like a dam. It acts like a barrier. Everywhere I've seen where dross is brought up onto the sill, there's always a pool of aluminium liquid in front of the dross. And when ultimately the dross is brought off the sill, even if it's been left there for a period of time to allow it to drain, when it's brought off the sill, that liquid ends up in the dross pans and goes out to the recycler. Here we press it, you can see we've lifted it, we've allowed drain to drip out. We've got a couple of choices there. We can now remove it out of the furnace and drop it. We can put it back down on the bridge there and then bring it off the bridge. The amount of time we press it for, it's all configurable, depends on the dross temperatures and the amount of aluminium that's in that dross. These days, it's typically about 20 seconds per press that we do. One lane is about 2 meters wide. So 2 meters width of the furnace is brought to the front of the furnace, pressed, removed from the furnace. What we see is a reduction in dross volume and weight. Why volume? Because we're compressing it. And weight is the liquid drain which stays in the furnace. We also see a cooler dross. So the thick cast steel that we have here for the blade and the cold plate absorb temperature. So the dross, immediately when it's deposited into the pans, is cooler. And at this particular facility, I measured temperatures immediately after skimming and then later after 5 minutes and 10 minutes. And the highest temperature I saw immediately after skimming was 500 degrees centigrade. And after 10 minutes, sitting in front of the furnace, that dross was down to closer, below 400, but closer to 300 degrees centigrade in most places. Conventional theory will tell you that dross will not oxidize further at those temperatures. So we get the dross in its wettest, warmest condition in the furnace, squeeze out as much liquid as we can in as short a time as possible, and then remove a cooler, compacted dross out of the furnace. Photograph on the left shows you dross without IFDP, without the pressing, and dross on the right after pressing. Cooler, sometimes solidified wafers, sometimes with a plating action there. So there is still aluminium inside that dross. It's a trade-off. We can spend longer pressing and press with a harder temperature, but we're extending the skimming cycle. So we've found that a natural point around about 20 seconds gives us that best benefit. I'm coming towards the end now, so we get to the point where we can take questions. Just a reminder of the benefits that we can offer through using rail-mounted equipment: increase plant safety, keep the operator away from the machine, plant productivity, maximize the volume of what you can get into the furnace and how long it takes you to get it into the furnace, improve refractory life by making sure that these machines don't contact your refractory, make those machines fully autonomous, take out the operator effect, not just from a safety point of view, but from a repeatability point of view. Reduce dross generation, again, by minimizing door opening times, and increase metal recovery through pressing of that dross and keeping the aluminium in the furnace. And I'll remind you that that is finished alloy, ready for casting, with no additional handling, no additional energy, no additional time. It's ready immediately. So ultimately, those customers who are using IFDP benefit from not having to put as much solid into their furnace to be able to cast the same amount of material. So improved yields. I'll just run you through a couple of recent references. I work from the bottom upwards. 2 machines supplied to a client in Taiwan. They're delivered. They're going into a brand new cast house that's being built at the moment. They're not installed or commissioned because the cast house is being built. Notice that they contain this IFDP in-furnace dross pressing. They're an autonomous skimming machine, 15-ton capacity charge machine. Project in the United States, another skimming machine with IFDP, autonomous, bi-direction, automatic skim blade and tool changeover. Very comprehensive machine. Installed, commissioned in the United States. Installed and commissioned just a couple of weeks back. 2 machines which have been delivered to a brand new cast house being built in the Madrid area in Spain. An existing client, but a brand new cast house. Those 2 machines are delivered. We're waiting again for the cast house to be ready. 4 machines going into a cast house in the Czech Republic, autonomous, IFDP, autonomous. Those machines went through factory acceptance testing during last week. They're in the process of being broken down and shipped to our client and will be installed in the coming weeks. Project in Spain for a skimming machine, again, existing client, a little bittersweet. This one, our very first skimming machine we supplied was 26 years ago, and that skimming machine has been in operation every day for 26 years. We will replace it this year with a modern generation skimming machine, and that one is in our workshop right now, will be factory acceptance tested in the coming days. Skimming machine for a client in the United States, installed and commissioned. 2 charging machines for the United States. These are in the engineering phase. Same cast house, a 15-ton and a 10-ton charging machine to serve different furnaces. Project in the United States for a charging machine, 10-ton with a rotation. This is an existing client, but a new cast house to us. Those are in the engineering phase. Skimming machine for a client in Hungary, existing client, but a brand new location for us. Will be the first time we've worked in Hungary. And a client in Belgium with a charging machine, 15 tons with a rotation. This is an existing client, existing customer. We know the cast house, and it's going in to serve a furnace that we're already quite familiar with. That brings me to an end. I'm aware I've talked quite fast to make sure I get all of the content in within the prerequisite time. I think I'm there. I will stop sharing and I'll be available for any questions.
Yeah, thank you, Mark, for the presentation. Let us start the Q&A session as we do not have much time left. Okay, to the person who has requested for the presentation, the recording of the session as well as the deck, along with the feedback form would be shared with all the participants within this week. Okay. So yeah, somebody says, please share your BD team contact details to request them for a visit to our factory and recommend solutions.
Will you tell us who that was so that we can
No, it's
visit them?
anonymous
I'm not.
attendee. Okay, so
Okay.
like if the person wants to unmute themselves and come on the camera and speak, you're always welcome for that. Okay, the next question is, hi Mark, this is from Dan Jackson. Can the system be integrated with the EMS controls, that is, stop the dross buildup moving during skimming?
Right, Dan. Nice to hear from you. We do know each other. Um, I wouldn't go as far as say integrated, but we can certainly give a signal that suggests that the EMS should be turned down, and that depends whose EMS that is and how that's controlled. You know that I used to work for a company that supplied EMSs. So that one, the power could just be simply turned down so that you don't get so much circulation. So the camera could be used and tuned to give that indication, but I wouldn't want to be the person who controls that, particularly since we know that that circulation also affects melt rates, productivity, and I wouldn't want to be responsible for slowing the furnace production down.
Okay, next question. Any ROI of the investment on each of the solutions in terms of value of benefits compared to the investment and the payback period? Lastly, broad pricing change for each of the solutions.
Right. So our price is not linked to the speed at which you get your ROI. If we install it and you get your ROI in a couple of months, we wish you good luck, and we have no problem with that. We would hope you'd come back and buy more from us. The cameras are obviously a different level of investment compared to the actual machines themselves. And I don't mind throwing out a price indication there that a camera costs around about 45 to 50,000 euros. And how do you justify the ROI on those cameras? We've heard people say that they've analyzed every time they open their furnace door, and this will depend on geography, location, costs involved, size of furnace. But we heard a cast house manager once tell us in United States, he believed every time he opened his door, it cost him 1,000 US dollars. That's quite a shocking figure. If he opens his door 50 times, he's just paid for a camera. So the idea is keep your door closed, make your decisions about your process with the door closed. One, safety, but two, keep the heat in the furnace. Every time you open the door, from a safety point of view, the burners should stop. And when the burners stop, the roof temperature starts to drop. Heat escapes out of the furnace. When you close the door, first thing you have to do is recover the roof temperature that you started with. That takes time and that takes additional energy. That's where the ROI comes back. I can't tell you how many times you open your door in what I would say is unnecessary actions. You've got to open the door to charge. You've got to open the door to skim. Can't stop that. But what happens around the world is every day people open the door several times to observe what is the state of the furnace right now. And even if you have a prediction system that tells you the furnace is going to be ready in 20 minutes, I'll bet you'll open that door after 18 minutes to see is it ready. And you might have just slowed the process down. Or you might say, well, let's give it 21 minutes just to be sure. Well, it might have been ready in 18 minutes, and you've lost those 3 minutes and will never get them back. So that's where the cameras start to pay for themselves. Allow the camera to tell you you have flat bath conditions, and now if you remove the dross, you'll get better heat transfer from the burners because the dross, which is an insulator, is now gone. You'll get your temperature to casting temperatures quicker. Right? That's cameras. Charging machines. I showed you a slide that said we've supplied 60 of those around the world. Many of those to repeat customers. Those repeat customers haven't just bought those charging machines because they like RiA or they like the look of our equipment. They know what the benefits are, and they've repeated that and repeated that again. So let's go back to what I talked about door opening times. I replaced the charging machine in India, which took 4.5 minutes to put 8 tons maximum into a furnace. And I provided a machine that did the same job in 50 seconds, and we could put 12.5 tons into the furnace. It's a 40-ton furnace, so the old machine would need to do that 5 times 4.5 minutes. So way over 20 minutes, 22.5 minutes, just for charging. I was able to get that down to 4 pushes, less than a minute per push, 4 minutes, save 18.5 minutes per cycle. Every cycle, in every day, every week, every year. So there's your productivity benefit that you start to see from having the right size charging machine operating at the best speeds, not even taking into account melt rate improvements by evenly distributing the scrap, or less dross generation by minimizing the door opening. Skimming, often a large part of the benefit here, which again is hard for us to quantify, but it's that protection of that refractory. We put a charging machine and a skimming machine into a client. I took some Italian visitors on a reference visit to that client in Germany, and they asked when the furnace had been relined previously. How long since you relined the furnace? That was the year 2022, just after COVID. And the client had relined that furnace in 2014 when they installed our charging machine and skimming machine and had not replaced the walls on that furnace in 8 years. And they put that down to our equipment protecting that refractory, giving them that improved refractory life, which one saves you in the cost of the replacement of the refractory, but more importantly, saves you 30 days downtime doing a reline. So there's a big benefit from that. If we can skim the furnace quicker than you do with manual equipment, manually driven equipment, often we hear it takes 15 minutes to skim a furnace, or 20 or 25 minutes. We'll be able to do that quicker and more repeatable with a skimming machine. So again, there's part of where your payback comes from. And then the autonomous side of it, I don't like the thought that I sell equipment and people lose their jobs because these machines are autonomous. I like to prefer to think that people's jobs are made easier and people's lives are made safer by using such machines. We have clients who've put these machines into operation and they've previously been using front loaders or wheel loaders with very high cabins. Operators had to climb up and down several times per day, and they start to get repetitive injuries in their knees and having to take time off work. That's eliminated with using these machines. They don't need to get onto such big machines up and down all of the time. A skimming machine we put in, the operators are no longer having to use the mobile equipment, and actually the operators, after they had skimmed, would close the door and then go take a sample from an inspection window, freeze a button, and take it to the spark testing. Actually, that process can now take place while skimming is taking place, because after that first lane has been skimmed, they can open the inspection door, take the button sample, freeze it, take it to the spark analyzer, which is just behind the furnace, polish it, take the test, and have the results before the skimming is finished. So those are all a combination of your ROI, and everyone's model would be different. We can tell you where you can potentially make those savings, but you'll have to put the monetary value to that because it's going to be different in every country around the world. I've stopped.